Okay, let me know once you start the recording. Where is Paris? Okay, Paris, are you there?
Yeah, Sarika, I'm here.
Uh,
Hold on one second.
yes. Have you started the recording?
Yeah, I just started recording.
Okay, fine. So we are discussing about the collections framework. We have multiple interfaces and collections, multiple interfaces and classes inside the collections framework. We know we already discussed about the list set. They all come under collections framework. We have something called linked list. This is also part of the collections framework. My question, like why we have so many classes? Why can't we just have one and use it with all the features? We have multiple classes depending upon our requirement. Okay, requirement changes from programmer to programmer. So we can't have everything. We can't have a single class fulfilling all the requirements. So we just use the different interfaces and different classes. As we discussed for list and set, the internal working of list and set is different. Okay, list doesn't allow duplicates and it preserves the insertion orders, and we have certain methods for list. Set also works in the same way but with little differences. Okay. Okay, did I tell you that set internally uses map? I think we haven't covered that yet. Oh, did we cover it? Okay, I told you that set does not allow duplicates, but how it is achieving that? We discussed that set doesn't allow duplicates, right? But how it is achieving that? How it is maintaining the elements uniquely? Anyone has any idea? It's maintaining is with the use of map. Set internally uses map. Okay, so when you create hash set, for example, when you create hash set, internally hash map will be created. How you insert the values to the set? We insert, let's take the example of a normal set. Okay, let's take a string set. Let's say my set, new hash set. Okay, I'm just creating a normal set. This is a normal set. This is how we create the set. In this set, we can only save the string type of elements. If I want to add some values, I will just add some values here. Let me repeat the same thing. Okay, let me just add few values. So this is how I create a set and I add the values. But internally, you know what happens? Internally, whatever value we write here. For example, I have Sarika value here. So I created a hash set, but you know, internally hash map will be created. Internally hash map will be created. And how the map saves the values? How a map contains the values? It contains the values as key value pairs, right? So each and every element, it will have the values as key value pairs. Okay. First section of the map would be key, and the second section would be value, right? So you know what happens? This is the key, and the second section is value, and it is same for everything. It is same for all the map elements. So you know what happens? Whatever value we insert here will be saved inside the key. Same thing happens with this value also. It will be saved inside the key. What about the value? What it contains? It contains some dummy object here. Okay? It contains some dummy object, dummy value. Dummy object value will be saved inside this key value. Instead of keeping it null, some dummy values will be saved by the compiler. It will take care of that. Okay? So my question, can we duplicate the key values? Can we? Strictly no. Key value should always be unique and they cannot be duplicated. That's how the set is achieving the uniqueness. That's how it is not allowing the duplicates. You can have only the unique elements inside a set. How it is working internally, because it internally uses the map. Whatever value you save here, it will be saved inside the key of the map, and the value will be some dummy value. So each and every value will be saved inside the key. We know like we cannot duplicate the key. That's how it's preventing the duplicates. Whenever you try to add Sarika again or with some value. Sorry, we have to give the key here, right? Okay, here, like whenever you add Sarika here, this will be placed here, or if you try to add Sarika here again, that will be simply, in map it replaces. So you don't need to worry about that. Okay, fine. So you understood how set internally works? Okay, so remember, now my question, I told you already, map is not part of the collection framework. This is yes or no? Map belongs to collections framework or not? No, it doesn't belong to collection framework, but set internally uses map. Okay, just remember that. Map is not a part of the collection framework, but set internally uses map, the respective map. Like if you use hash map, hash set, the respective hash map will be used. Okay. Okay. So any doubts in this? Okay. So this is the
Yes.
internal working of the set. We know, like for list, we don't have any such internal working. List is internal, it is backed by an array, and we know, like it is dynamic again, and the initial size. We know the initial size, right? What do you mean by the initial size? Initial capacity. Initial capacity. Size and capacity both are different. And initial capacity of set. Initial capacity of the list would be 10 and initial capacity of the set will be 16. Okay. And what do you mean by the size? Capacity is different, size is different. Capacity is something, how many numbers it can hold. That is capacity. And size is something, how many number of values it contains. Okay. So initial capacity of list would be 10. Once you start adding the elements, the list size will be increased. Same with the set also. That's why we call the list and set as dynamic arrays. Okay. So this is the initial capacity of the list and set. Okay. And so map is not part of the collection framework, but it is used by set. Okay. Fine. So let's discuss about the linked list. What is a linked list? It is the items. Okay. Fine. Let's discuss about the linked list. Let me show you the hierarchy before that. Okay, let me just show you the hierarchy. One second, let me share the screen. Okay, let me just. Can you see the screen? We know the root interface of the collection framework is the iterable, and it is extended by the collection interface again. All these yellow color ones are interfaces. We know that, right? So we have linked list. So linked list belongs to list and queue both. Okay. It inherits for some features from the list. Also, it inherits some features from the queue. Okay, let's see how it is related to the list and let's see how it is related to the queue. Okay, so linked list. My question, how the values inside an array list will be saved? So this linked list is something which is not related to set or map. So don't think about them. Just think about the array list and queue. Okay. So my question, how the values inside the array list will be saved? Anyone has any answer for this? We discussed this already. The elements are saved in a contiguous memory locations. They'll be saved like this. See, if you created a list, your 10 memory allocations will be allocated to your list in the contiguous memory. They'll be continuous, right? They'll be next to each other. And whatever element you insert here, it get inserted one by one. If you click on add directly, the element will be saved at the end. But if you mention the index and add, the particular element will be saved at the particular index, right? Okay, but it is different from array list. The internal working of a normal array list and the internal working of linked list are entirely different. You know, the linked list looks like this, and let me just save you. The elements will not be saved in the contiguous memory locations like this. What do you mean by continuous? You can say continuous memory locations. But in case of linked list, it is not like that. Each and every element is called as an object. It will be referred as an object, and it contains two parts. It contains two parts like this. This is the first element. This is the second element. This is the third one. You can have any number of elements. You can have any number of elements. The second part is used to point the header of the next element. Okay. So let me just show you the hierarchy here. Okay. Can you see this? Let me just scroll a little up. Okay. Can you see my screen? This is how the elements of the linked list are saved. Okay. Here I need to insert one more block. Sorry, I need to. This is for the next node. Let me add it clearly. Okay. In the middle, we will have the value. Let's say, for example, how we create the linked list, it is same as the array list. What is the syntax for creating an array list? We create an object for the list, correct? We will mention array list of type, it is string or integer, then the array list name equal to new array list. Even for linked list, we'll do the same thing. We will create the linked list, we will mention the size, again equal to new linked list, again type. Okay. So here, whatever value we do, if we say, for example, list at add, here we are saying, this is about the doubly linked list. Let me go here. Let me go here. This is about the array list. Just a minute. Okay. Can you see this line? Let me just copy this here. Can you see this one? First line is the syntax of creating a linked list. So if you can see, it is just like creating an array list or not. It is not difficult. You are mentioned the linked list. This is the type. You can also give the object type here. And this is my linked list name. Linked list name can be anything. Again, U is for creating the object. Linked list, again the type. In just like how we add the elements to set or list, we add the elements to linked list using the add method. So what happens, this Ravi name will be saved inside the this particular block. Okay. This Ravi name will be saved here. This Vijay name will be saved here. Let me divide the second one also. Let me divide the second one. Again this one. Again let me have another block. I don't have space there. I'm just adding another block here. Okay, so the values are saved like this, and it is saved here. Ajay is saved here. The first element is always called a head. So what this we call as, this is called as head. The second element will contain the value, and the third portion is used to point to the next element. Okay, this particular portion is used to point to the next element. And for this particular object, for this particular memory location, this one is used to point the previous element. So this is how the pointer, we call it as pointers, pointer object. This is how the pointer objects works in list. Is it confusing? So this is how we point the elements. Here again, this points here. This again points to this. Again, we have each and every element like this. What about the last element? I have 4 elements inside a list, and the last element is not pointing to any other value. So it will just contains null. Okay. So whatever elements we insert, it will be saved inside the middle section. Okay. This is about the first value. This is about the second value. So this is a dynamic array or the size is fixed? First of all, is this an array or something else? See, either it is a set or array list. Internally, it is backed by an array. We know even in the array, the elements are saved like this, right? So the list and set, they are backed by the array. But the linked list, it is not backed by array, but it is backed by doubly linked list. If you are interested to learn about the doubly linked list, you can go through in the Google. It is all about dividing the memory objects as an object and pointing out to the next element. This is how the elements are saved in the linked list. So my question, why we are going for it? It looks very complicated. Why don't we use the list and set? Why we need to use the linked list? So anyone understands anything? Okay. See, list and set, they have some limitations. For example, I have 10 elements inside a list. I am removing one element. So all the elements will be updated or not if I am removing one element. Not only with the removing, if I am adding, for example, I have 10 elements, and at the second location, I am adding another element. So all remaining elements will be updated. They will be moved to the next memory locations or not. Yeah, that is what the advantage of linked list. If you want to add the element, update the elements or delete the elements, the other element they won't be affected. Okay, it is about it is very useful for the updation and deletion operations. If you want to update your list, you see you are creating a list where you are expecting you may need to update a lot. So in that situations, you have to use the linked list. Okay, as I already told you, it is a map or set or list or linked list or queue or something else. It totally depends on your requirement. We have so many things just to fulfill your requirement. Okay. Okay, let me just show you some definition and the basic stuff, methods related to the linked list. Okay, just try to understand. Linked list class uses doubly linked list to store the elements. and it provides the linked list data structures. It also inherits the abstract sequential list and implement these two interfaces. It implements list interface, queue, DQ interface. Okay. Okay. See, just like an normal list, linked list is also part of list, so it is allowed to contain the duplicate elements, and it also maintains the insertion orders. It is not synchronized, so you cannot use it in the multi-thread applications. Okay. Okay. So the main advantage is manipulation is fast because no shifting needs to occur. In a list, if you want to add one element, the other elements has to shift towards the right or left. But in linked list, if you want to add the element here, simply the particular pointers will be changed. You add one more memory block here, like this. Add one more memory block, and these pointers you have to point to this particular block. Other blocks, they won't be affected. This is the main advantage of the linked list. So this is how the values are changed. The first, okay, sorry, this is the doubly linked list. Let me explain the linked list. Okay, so this is the hierarchy, and so this is how the elements are saved. The first element is always called head. Head pointers to the first element. Again, the values will be pointed to the next element. So this is how it works, and let me just show you with a normal example. See, if you are confused from the memory part, you just see it from the programming part. Okay. Okay, let me just create a project. Okay, let me share my screen. Can you see now? Okay, fine. I'm just writing example. Now you have to tell me how to create a linked list. Let me quickly create a class. My student LL linked list example. Okay, how can I create the linked list? Can somebody help me here? Okay, it is the same. You just give linked list here. Again, you just mention the type and my student list. This is the linked list name. Name can be anything. So let me just save the names here. So names belongs to string type. Again new. Again the same thing. Let me copy. It is very simple, right? It is just like how we create a normal list. Let me just import it. Syntax for creating a linked list. Okay. Okay. So can I, what if I make it as remove this? Will it work? Will it work? It's working. Why? Because we know that, like, you can give the interface reference to the respective subclass. Correct? It will work. Even this is also fine. Both are fine. Okay. Okay. How can I add the elements? Now tell me, what is my linked list name? What's my linked list name? Yeah. So if I want to add the elements, or if I want to see the methods, let me just put dot. These are all the list of methods which are available to the linked list. Okay, let me just, I want to add some elements. Fine. Let me, this is the student linked list. So let me add some values here. Password and let me add align. And let me, who are there in the meeting? G1 Paris. It is just the same. We are not doing anything new. Okay. So what if I want to print these elements on the console? In how many ways I can do that if I want to print?
for each, or just print out the list.
I can't hear you.
You can use the for each, or you can just print the list by system
Okay.
out.
Okay. But now, this time I want to use the iterator. You can also print collection element is the using the iterator. Okay. So what is an iterator? Let me just iterator in Java. Okay. Yeah. It is an interface. It is provided to iterate through the elements for a collections framework. Okay. So it is specially for the collections framework. It belongs to the collection framework. If you can see the word, English word, iterator, it iterates through the list of elements and it will help you print the values. And it has importantly three methods. Has next. What do you mean by the word has next? Has next is a boolean which returns true if your list or set, whatever the collection you are using, has the next element. And we also have the next elements. This return the objects. If next element is not present, it returns no such element exception. Okay. Again, we have remove method to remove the current element. And what is the syntax for writing the element? Simple, iterator. So if I want to use the iterator, first I have to declare it. Let me just write is an interface which belongs to collection framework. Okay. Use it to iterate through the list of elements. When I say list here, again, it is not array list. I'm just saying this list of elements, okay? It can be anything. So if I want to use this iterator, this is an interface. So what I have to do? First, I have to write the syntax. Then I have to use it, okay? So this is the syntax for writing the iterator. So here I have to give my list name. Let me give my list name. Okay, I have to import it. I have to import java.util. Please observe, you have to create a iterator object. You can get through list.iterator. Okay. Now, how can I use this? Do I need to use it with while or for? Can I use while? What they are using here? Okay, let me just try it. So how it works? Please observe, I am just giving the values here. So I will just give my object. And I told you how many methods iterator has. We just saw now. It has 3 methods, right? So what I'm trying to do here, print the list of elements until the iterator has some value. So I just give here has next. If it doesn't has next, this returns false. When this becomes false, the control comes out of this loop. So until this condition is true, execute this loop. Okay. So we don't need to give any increments or decrement. It will simply check whether this particular iterator, which belongs to the list, has the next element. If it has the next element, print it. If it doesn't have it, this returns false, come out of the loop. So iterator has next value will always be either true or false. In which situation this becomes true? If the list contains some elements. Is that clear? Okay. So now if I want to print it, then I will say print the next element, whatever is it's going through. So shall I run? Any confusion with this iterator and the loop? You can print it normally, but like I want to teach you about the iterator, so I'm just explaining you. Okay, why 19? You have any doubt? You can ignore it. Like if you have any problem, error, then only you have to consider it. Now
Mm,
what? Tell me what's the output? What output I'll get if I run this? The names. Okay, let me just give normal sys out here. What is the output of this one? Let me type here iterator output. Okay, I'm going to run it. Right click, run as Java application. So can you see this? If you put through the, if you print normally, it gives elements like this. If you print through the iterator, it will give you one by one. So it is the same way. There is nothing new with the iterator. It is one more interface which is provided to the collection framework. It you know why we defined it specially? Because it contains three methods which are really helpful. If you want to print the elements, or if you want to check whether it has next element or not, it has useful methods. That's why iterator interface is regularly used with the collections framework. Is this clear with the linked list? Okay. Okay. So just tell me, like, your requirement is you want to save the list of values which should not contain the duplicate elements. Then you use which collection framework class? Which one you use? Correct. Everyone has to reply me. Okay. Okay. For example, if I want to create a list where I want to make the regular updation operations, I may need to insert the values again and again. So do I need to use the set or list or map or linked list? My requirement will change. Like I need to add the elements again and again. So which one I have to use? Linked list I have to use. You know, somebody said list. If you use list, every time you insert a new item in the middle, all the other items have to shift. Okay. So if shifting operations, if updation operations are needed, then you have to use the linked list. If you use the linked list, only the pointers will be changed. You don't need to shift other elements anywhere. That is the advantage with linked list. Okay. So that is the difference between array list and linked list. We frequently use array list in our real-time world, but in some places where you need to update, there you have to use the linked list. Okay, set is, what is the disadvantage with set? Anyone know? Anyone has any idea what is the disadvantage with set? It is not faster. Every time when you insert a new element to the set, it has to check with the existing elements whether the new item will be same as the existing item or not. It has to check for the duplicate thing. It has to take care of that, right? So that's why it is not that faster. So we regularly use array list. If you want to use something which is useful for the updation and all, then you have to use the linked list. So this is how linked list works. Anyone has any doubts? We will come to it again, like in this week we also discussed there was a super keyword and all, right? In the same way, the collection is a huge topic which you cannot cover in 1 or 2 days. So we also have some pending topics: exception handling, serialization, IO streams. Then we'll come back to this queue linked list again. So if you don't understand it, don't worry about it. Just try to understand, try to practice. Is that okay?
Sorry, good.
Yeah.
In that, did you initialize iterator or is that a object creation? The 21.
See, iterator is particularly for the collections framework. Okay, and it is an interface. You cannot instantiate the interface. So the implementation is given in such a way that you can just add the method of it. We are just using the method with the list. It is allowed to use the method with the list. Okay.
So
Let
that's the
me just
syntax.
show you here. Yeah, that is the syntax, and these are the list of methods. How we take it. You can give your list and you can use its method. You can create a, we are not creating object, but like we are creating the iterator. Okay.
Okay.
So this is a syntax you have to follow. Is this fine? Okay. So I will give you brief introduction about the queue. Then we will discuss more about the queue and linked list tomorrow. I will do one thing. Tomorrow I will start exception handling. Then I will come to this collection framework again so that you will not forget it. That's better. Queue interface in Java. Anyone has any idea on the queue interface? Queue is a part of the collection framework or not? Okay, you have to remember FIFO for the queue interface. First in, first out. Just like queue is again the contiguous memory locations, but whoever is inserted first will be removed first. First in, first out. For example, assume that this is a queue. What is the general meaning of the queue in English? Queue is a line where we stand, right? In the outside real world. So whoever stands in front of the restaurants or anywhere, they will be given the token first. And okay, can you see now? So queue is again the interface of collections framework. So whoever is inserted first will be removed first. First in, first out. That's why we say queue works in the first in, first out fashion. Okay, first in, first out. So whatever element we insert first will be removed first. And we have certain methods. We have certain particular methods which are related to queue, which are used to remove the element, add the element. Okay. So for example, this is my queue. Here I have the list of items and I already saved some values here. For example, I saved some student values here. And so, okay, I have for example, I have 4 values. Now, if I try to add Prashant to this queue, where it gets added? Where it gets added? I have these many locations available. Yeah, it gets added here. It gets added at the end of the queue. I mean, till where you have elements, after to that, it gets added. And if I want to remove the elements one by one, who is the first one to remove? I have 4 persons here. Who gets removed first? Are you sure? Think and tell me. Yeah, this is something I wrote here. You have to remember it. I think the last in for first out will be for the stack, right? You might have remembered the data structures already. So the first one who is in, he has to go out. So if I start removing the elements, the ln will go out. Again, these people will be shifted here. Next, again, G1 will go out. So this is how the queue works. Again, if you want to create a queue, it is again similar to the linked list. Let me show you. So can you see this, please? Queue interface is available in java.util package, and it is used to hold the elements about to be processed. We'll understand the importance of the queue. There are different differences between all the interfaces, right? So the queue is little different from the list and set. We'll discuss that about later. So it works in the FIFO fashion. First in, first out, and whoever are implementing queue interface as priority queue, linked list. We talked about the linked list some time back. So in the same way, priority queue also works. We'll discuss about this. It has the subclasses just depending upon the different requirement. And these are all the different methods available. So This is just used to see the first element. Okay. View the head. Head is nothing but the first element without removing it. Okay. And we have one more method, poll. This returns first element, also remove it. If you just want to see the first element, use pick. If you want to see the first element, also remove it, then use poll. These are the different methods available inside a queue. And how we declare a queue? So can you see this? It is just like how we declare the list and set. Here you can use either the linked list or priority queue or other subclasses of the queue interface. Okay. And here they're adding, you can add directly using queue.add, or you can, here he is just using with the for loop. Okay. Again, he implemented using the few methods, size, peak, and all those things. So shall I explain this queue tomorrow? Okay. How many of you are comfortable with this linked list? Got some idea? Okay. Because this is a little complicated. Okay, fine. Tomorrow I will do one thing. I will take 15 minutes of time and explain about the linked list again. Okay, so tomorrow we'll start the exception handling and defining this user defined exception. I will think whether to discuss tomorrow or day after tomorrow. This will be a little difficult. After the exception handling, I'll discuss about the queue and linked list. Okay? Okay, you can stop the recording, Paras.